we pass to the next speaker or speakers, maybe Benjamin Roberts and Alan Williams, who are also very well known. And they both have been researching for many years early metallurgy all around the places, and particularly, of course, in the British Islands. And they are going to present their project Ancient Tin 2020-2023, Bronze Age tin exploitation in Southwest Britain. I don't know who is the first speaker now. Ben?
Yes, I will be speaking for the first few minutes, and to the relief of the rest of the panel, it will then be Alan for the remaining presentation. Okay. Thank you very, very much, everyone. Good afternoon. Thank you in particular to the organisers for convening this fantastic roundtable. Alan Williams and I are here today to introduce our ongoing work on a 3-year project funded by the Leverhulme Trust on ancient tin, with a focus on the Bronze Age and on the sources in southwest England and beyond. Next slide, please. As everyone in this roundtable knows very well, there are more than 50 radiocarbon dated Bronze Age copper mines across Europe, and likely many, many more sources still to be confirmed that were exploited. We also have some sort of consensus from a workshop led by Miljana Radovojevic and myself, and involving several members of the panel and attendants, that there is a upscaling, an increase in the exploitation of copper ores at major centres around 1600 BC. There weren't many consensuses on other points around tin provenance, which was interesting. Next slide, please. Now, as everyone knows very, very well, tin sources are very scarce indeed, and we're still, I think, over 150 years on from when the debates really started in the 19th century, debating the relative significance of major Western European sources, as well as Anatolian and Central Asian sources. Next slide, please. What does appear to be clear from work by Lawrence Rahmsdorf and others is that when you start plotting the early evidence for tin-bronze alloying, you tend to get earlier dates towards Southeast Europe, and you tend to get later dates towards Northwest Europe. And so what we're seeing is a pattern of the very earliest alloying going from Southeast to Northwest. However, as Ernst Pernitzker, Chris Pear, and others have identified, you have a pattern from Northwest Europe of full tin-bronze adoption that actually occurs later in Southern Europe, where you have full tin-bronze adoption, a term that Helle van Kilde has designated as bronzization. And this is really a key departure point for our work. And over to you, Alan. I think you're muted. Alan?
Okay, thanks, Ben. Sorry. Greetings from Cornwall. Salute della Cornavalia. Interest in tin studies has been growing in recent years as finds increase and analytical methods improve. I mean, here are many of the papers that have appeared in recent years, and that I'll mention a couple of them. The German-led Mannheim ERC project on Bronze Age tin was based on using the newly perfected analysis of tin isotopes. They analysed tin ores from many regions and also on selected metalwork. They found many overlaps in tin isotopes that limited the conclusions they could make based on that measurement alone, as Daniel explained earlier. The team then started to use the three-pronged analytical approach of tin isotope, lead isotope, and multi-chemical analysis that we've also adopted in our project. They looked at the Israeli Bronze Age tin ingots and linked the tin to European tin deposits based on geological age determined from lead isotope data, as we've been hearing about earlier. However, they could not be absolutely certain about which European deposit, but they favored Cornwall based on high indium levels, but lacked enough information on ores and tin and smelting to be more certain. And our project should help address that issue and build on their work. The US team that we've heard about today has recently published a paper on possible tin sources for the ingots from the Uber-Luban wreck, which has also been mentioned today, suggesting a Central Asian source and a Turkish source. But this, a lot of this assumes a low thorium level in the tin ores, which I'll come back to in a minute. We're looking at whether Britain was a major supplier of tin into Europe and beyond. From work I did a few years ago, we know that copper from Britain's Great Orme copper mine reached Europe at the mine's peak around 1600 BC, probably as bronze pal staves. So could the tin from southwest Britain somehow have been linked to these exchange or trade networks? Also, we have links with Sicily suggested from the strumento object found on the Salcombe shipwreck, and Needham and Guardino have suggested other links as well. We can add many other things suggesting links with swords and shields, etc. This is the proposed technology of Bronze Age copper in Britain. After the probable self-sufficiency of the Great Orme boom ending around 1400 BC, the current evidence suggests that Britain's copper was mainly imported from mainland Europe, probably from the Eastern Alps. A key question is whether Britain was exporting or exchanging tin to large areas of Europe for copper. Did tin from Britain help enable the bronzitization across the continent and beyond that Ben mentioned? Here's a map of where Cornwall and Devon is situated. So what evidence do we have to support that Bronze Age tin exploitation in Britain? Many of you will be familiar with the classical texts, some of which date back to the Iron Age. The account attributed to Pythias the Greek in 320 BC describes the tin workings in Cornwall, Berluria, and the trading island of Ictus, probably St. Michael's Mount, although this is debated. He then describes how the tin is transported to Gaul and reached the mouth of the Rhone in 30 days. More evidence, although with little detail, are the numerous Bronze Age antiquarian finds found during the 18th and 19th century during the reworking of tin streams in Cornwall and Devon. However, there's been a series of very interesting, more recent archaeological finds providing evidence for tin exploitation. Firstly, the early Bronze Age tin finds in the kist burial on Whitehorse Hill in Dartmoor in southwest England, excavated in 2011, consisting of 32 tin beads in a cattle hair band, and also a tin bead from a necklace. Secondly, the exciting discoveries from the Tugura Valley near Truro by the Cornwall Archaeological Unit. In several pits associated with roundhouses were over 10 kilograms of cassiterite tin ore in the form of pebbles and crushed materials, including a stone crushing tool or muller. They are dated to around 2020 to 1770 BC. Furthermore, there are several other roundhouses to the west and north of Truro, and one on Dartmoor, in which cassiterite has been found, suggesting workings in many areas. a decentralized form of production involving numerous settlements seems likely. Thirdly, an antler pick found in a tin working in 1790 AD in the tin-rich Carnan Valley in Cornwall was recently dated to around 1600 BC. Antiquarian accounts state that these types of picks were commonly found in reworked alluvial deposits. Fourthly, the well-known Salcombe shipwreck metalwork finds that included 40 tin ingots, dated by association with Bronze Age metalwork to the late Bronze Age. There are also several finds of tin artifacts across Britain, most recently at the Must Farm Roundhouses site in eastern England, a site frozen in time after a sudden fire and with amazing preservation in mud, has revealed a tin bead. We're also keen to find other prehistoric artifacts for analysis from any country. And so if any of you can help us with that, please let us know. So what are we doing in our project? Well, firstly, we've put together a GIS database for Devon and Cornwall, incorporating all the relevant archaeological and geological data, looking for associations and patterns using spatial analysis. Here's a simple distribution map of burials and also of gold metal finds that may indicate wealth, concentrated here in West Penwith. We're also looking at several areas in detail as case studies, including West Penwith and Dartmoor. It's important to understand that tin deposits can be in the form of hard rock deposits, e.g. veins, or as heavy mineral accumulations in soft alluvial sediments, whereas copper deposits can only be in hard rock deposits like veins and do not form alluvial deposits because the minerals decompose. The hard rock tin deposits are associated with granite intrusions, shown here in red. The other map is a GIS density map of tin veins, highlighting the areas with the most tin veins. And we're doing similar ones for tin placers. The richest alluvial deposits are associated with rivers that drain these areas of tin veins and act as pre-concentrators and pre-crushers of eroded vein tin. Here you see a geological map and one of the richest areas of tin veins in Europe around the Carmanellis granite being drained by the famous Carnan River, a probable source of gold for the Nabra sky disk, and its rich alluvial deposits where the pick that we described earlier was found, and many more reported. Most tin veins in hard rock may not have been worked until much later times, because the placer tin ore or alluvial tin ore, which is found in the valleys draining areas of outcropping veins, are much easier to work. The heavy tin ore is concentrated after erosion into tin-rich layers in the same way as alluvial gold, which is also found in Cornwall, as we mentioned. Here you can see the tin placers are widespread in Cornwall on the left, and on the right you see them on Dartmoor, around the Dartmoor granite. A common misapprehension is that heavy tin ore was just work in the active stream bed. However, the richest beds of alluvial tin were formed from many cycles of erosion over many thousands of years and are often buried deep under later barren sediments in valleys. Some can only be a meter or so below the surface, whereas others can be 10 to 15 meters deep. Hence, some alluvial tin was more accessible than others in the Bronze Age. It's important to understand that we're not dealing with a single large mine like a Mitterberg or a Great Orme. We are dealing with a landscape that has numerous valleys having alluvial tin layers present that can be harvested with simple tools and easily smelted. Look at the LiDAR image on the right of tin workings from medieval times and their sheer scale. Cornwall and Devon have probably been more or less continuously worked for tin for 4,000 years. It was one of Britain's major exports in medieval times, supplying most of medieval Europe. Whether this reaches back to the Bronze Age remains to be seen. Open cast surface workings are more difficult to work, but could have been exploited in special circumstances, especially in china clay areas. And so we were including those in our study. And here you can see some surface workings in Cornwall and in Devon. So our sampling program encompasses alluvial tin and vein tin from many museums and private collections. We now have a large collection and that we are using for our analytical work. We have also obtained from our European collaborators at CEZA at Mannheim, thanks to Daniel and his colleagues, and elsewhere, samples of cassiterite from other European tin ore regions for comparison. In addition, we undertook 2 months of field work last year across Cornwall and Devon, panning streams for tin ore samples with varying degrees of success. In parallel, we have sampled tin artifacts in Cornwall and Devon, not only from the Bronze Age, but also from all periods, to assist our aim of characterizing all the varieties of tin in the region. We don't believe there's just one sort of Cornish tin, we believe there will be several types. We and some of our locally based contributors have or will smelt pre-analyzed tin ores to see the changes that take place in trace element levels. Our analytical approach is similar to the one that Daniel described, used 3 independent analytical techniques to help us overcome overlaps with tin isotopes, lead isotopes, and multi-element chemical analysis. We plan to characterize the various tins from the different parts of Cornwall and Devon relative to other European deposits. We hope to be able to detect tin consistent with sources in Britain, elsewhere in Europe, and potentially in the Mediterranean. Cassiterite is hard to dissolve and presents major analytical challenges, especially with some of the old data. And despite COVID-related delays, we are now making progress. Here are some of the sample locations that we've got material from and that we will be using in our analytical program. Past stream sediments suggest that we might find different chemical and isotope characteristics in different areas of our region. And as Gilberto mentioned earlier, thorium, for instance, is high in some areas of Cornwall, and that has an effect on the lead isotope data. So watch this space. This is our website with lots of pages of information. Here's our interdisciplinary project team and our many project contributors in locally and elsewhere. Thank you for listening, and I hope we can meet up in person in the not too distant future. Thank you.
Thank you very, very much to both of you, Ben and Alan, for this excellent, excellent overview, in particular, yes, so the description and for showing us so many photographs also of the pieces, which some of them I didn't know, I had never seen. I think there will be a lot of discussion afterwards. We come now to...
Wait a moment, Moritz Jansen.
Moritz Jansen, yes, now.
Sorry. Moritz Jansen in the program was before Ben and Alan, yes.
I'm sorry,
yes. Moritz Janssen in the program was before.
Before
Yes.
Ben and Alan.
Yes, doesn't matter, but
Moritz, Entschuldigung, es tut mir wirklich leid.
No
Ich habe es
problem.
übersehen. Ich habe dich aber nicht vergessen. Moritz Janssen is a researcher at the Bergmau Museum in Bochum, and he was teaching archaeometallurgy in the Pain Museum in Philadelphia. He also came to Crete, and he's he has been working for years both on the provenance of gold and on isotopes. I think now his main research interest is isotopes, and he is giving us a presentation with the title New Isotope Research on the Tin Cargo from the Shipwreck of Ulburun. Moritz, is your turn.
Thank you. Do you see the screen?
Yes.
Perfect. Okay, thank you so much. Thank you, Fulvia Schiavo and colleagues for organizing this nice conference. And of course, also thanks to Alessandra for inviting me to this round table. So this is a perfect opportunity for me also to present or report on some new developments that we have in Bochum. And for this, using a prominent case study, the ingots of Ulburun. So we got some new developments here in Bochum because we installed end of 2020 a new mass spectrometer at the research laboratory of the German Mining Museum. And this one is a multi-collector ICP-MS, so it allows high precision measurements of different sorts of isotopes. In addition to that, it also integrates well in our existing lab infrastructure. Since about 10 years, we are already doing ion exchange chemistry, for example, for lead isotope measurements here in Bochum. But in the past, we had them always sent to Frankfurt, to the university, where Sabine Klein was collaborating with us, and we could measure the isotopes there. Now, as Sabine is the head of the archaeometallurgy department in Bochum, it absolutely made sense to install such a device also in Bochum. And of course, end of 2020, it's pretty fresh, and I had to do homework. And what we did was, next to pure standards measurements to prove our accuracy and precision, we also analyzed legacy collections, which were well characterized. And of course, we also want to investigate non-traditional isotopes such as tin, but the daily business, of course, as you know, in archaeometallurgy is a lead isotope composition. One of the case studies I chose were the ingots from the Carmel Coast, which are the actual pieces that were cut off by Bob Madden some 40 years ago, and these were handed over to Andreas Hauptmann during their study on the Ulburun ingots. The benefit of this sample set for me now to reanalyze is that it's of course well characterized, and you know the great paper by Berger and colleagues 2 years ago, but they were also characterized before, for example, by Begemann et al. So in total, we have 13 samples to compare, coming from Hishlo, Carmel, Kefir Samia, Haifa, and so on. So what we did was we were adapting our ion exchange chemistry to tin and reanalyze this set. And as you can see, we get a full consistency here with the lead isotope data determined by TIMS, by Bergmann et al. And if we consider the flip of some samples suggested by Berger and colleagues, also for the multi-collector data, we get full consistency. In addition to that, looking at the other ratios, that means that all results that can be pulled from this data is comparable to what have people done before. We also did first tests on these for the tin isotopic composition. Of course, interlab comparison is more difficult here. Of course, we still don't have a certified reference material that is commercially available. So many thanks at this point to Dr. Brückmann and the Kurt Engelhorn Zentrum for providing some of the JMC Puratonic tin metal, which is one of the two major sources which are still in use today. And if you look at the data and considering the analytical uncertainty of both sample sets, we get consistent analysis also for tin. Moving forward with the tin, it absolutely made sense then to analyze some of the other old legacy collection. And the Mining Museum, of course, is strongly tied to the Uluburun shipwreck. We had the first international exhibition outside of Turkey for this shipwreck. And of course, there was a preceding work of Hauptmann, Medding, and Prange on the structure and composition of copper and tin ingots excavated from the shipwreck of Uluburun. And our research goal is similar to what we have heard before. We want to analyze the lead isotope, the tin isotope, and the trace elemental composition of these old sample sets. I have to emphasize that all these are fresh metals, so we are not dealing with corrosion, which is a good point. Only one sample had some corrosion, but there were still enough fresh metal drilling curls which could be extracted from this one. So this one was already mentioned several times today. There's this new paper also just published last month by Wayne Powell and American and Turkish colleagues, and Ehud Galili from Israel, of course. And so this is also a great source because it also comes with a database. So key points to discuss, as also Sophia discussed earlier this day, was already stated some 20 years ago, that there are these high lead contents in some of the tin ingots. And if we speak about high lead, this is of course not too comparable if we speak about a high lead bronze or something. It's just a threshold of 100 ppm and more. So Paul et al. Follow the discussion and connect these to the Boldadak region of the South Central Taurus region. In addition to that, there's a second group which has low lead contents, and they discuss, as we heard several times, it could originate from European, but also from Central Asian deposits. And they favor the Tian Shan Mountains based on 208 to 206 lead ratios. In addition to that, the compilation of a database. So we have 91 ingots analyzed by Stoscale in the former Isotrace laboratory. And then they provide their own small sample set of 13 additional ingots, which were not measured before. And they did that with multi-collector ICP-MS at the University of Rutgers in New Jersey. So a great source to compare with our own data. In this diagram, you see the three most abundant isotopes. And what you can see here is that all our data sets well agree. So you have the multi-collector data from Bochum, the TIMS data from Oxford, and the new one from Rutgers. And you see we still get the two groups. One has elevated lead contents, especially in this region, and the other one is lower in lead in this region. So one of the benefits of multi-collector ICP-MS is, of course, that you can measure with high precision. And that is, of course, also a benefit for the low 204 ratios. And if we compare now, first of all, the lead 204 compositions of the Oxcalit or the Oxford database and the new Rutgers data, for the old Oxford data, you see most of the TIMS data with high lead is plotting with lower 206, 204 ratios, which makes that makes sense, of course, because of the lower influence of uranium, and the low lead ones would have higher ratios in that. Here are two of these ingots. They are at the limit of the threshold. So one has 102, one has 106 ppm of lead, still a little bit more than the others, but that is not too worrying. What is a little bit strange is that we also have some shifts in the isotope ratios for the new multi-collector data. So 5, which are 5 of 13, is nearly the half of them, has the lowest ratios here and also the lowest ratios here. So that's our starting point. And now we can put in our own data. And what you see here is our subgroup of high lead samples, which have more than 100 ppm of lead. And these are the results from the TIMS measurements, mostly from Sophia Stoss scale. And when we put in our new data set from Bochum, you see they get much smaller. So we have a very tiny variation here, which of course is a benefit of the multi-collector technique. Even samples with low lead contents, we don't need as much sample material to get really accurate results from that. So that is for the high lead samples, more than 100 ppm. And when we look at the low lead samples, and these are exactly our ingots measured with TIMS and multi-collector data, and we remeasure them in Bochum, we get again decrease in the variation on the 207, 204, just because of the higher precision of our multi-collector data here. So when we just look at our two data sets, they don't have this high scattering. They don't scatter so much in the thorium direction that we heard before. It's clearly a little bit different from what was known before. If we look at the 208, 204 ratios, again, the field of the high lead samples, more than 100 ppm, in Bochum is a little bit smaller, and the one for the low lead samples more or less remains the same. So all the results that Paul et al. Are recently also taking from their data set is still valid. So this is just our data, a little bit more separation. I don't want to restart the discussion that was led by Paul about the Bolderak high lead samples. Sophia Stoss-Gale already mentioned that it is clearly a contamination of lead that is connecting the ingots, the ingot production to the Kilisya region in Turkey. That was nicely shown. What I would like to do is focusing on our low lead samples now. And if we go back to the first part of my my lecture, I told you that we also analyzed the Israeli ingots, and this is what we get if we pool the data together. So we get a total overlap of our Israel data also in this one. And this was shown by Sophia Stossgale for the main isotope, for the major isotope compositions 20 years ago already, that there's a significant overlap in Israeli ingots and the low lead ingots from the Carmel coast. If we go even a step further and now pour in the data by Berger and colleagues, they nearly measured twice as much as ingots from the Israeli coast. You see that our low lead ingots from Ullebrun are perfectly sitting on the isochron of 290 years, plus minus 20 million years. But something like this here, for me, looks like an analytical artifact and should be maybe or could be corrected in future by additional measurements. So this one you already saw. What Paul et al. Are doing is bringing back the Central Asian deposits into discussion. So basically we have two alternatives, which is that we get European tin. Berger and colleagues are favoring the Cornwall ingots coming into the Eastern Mediterranean, or we are following the traditional idea, which is also based on textual evidence from Mari, from Kanish-Kultepe, for example. And this would mean that we rather deal with Central Asian material that is coming to the Eastern Mediterranean. So the closest we could get to the ingots or to the discussion of the text is, of course, Berger and colleagues are arguing that we are in the late Bronze Age with our Israeli ingots. So that means we are several hundreds of years after the text from Mari and Kanish-Kultepe. To my knowledge, the closest we can get is with a tin ingot coming from the Minoan town of Giorno, which I was able to sample with Vance Waitris and Don Everly a few years ago. And this one was found in 2012, and it's dating to the late Minoan 1A, so 1600 to 1500 BCE. And of course, that slightly predates also our Mochles sample that was analyzed by the Mannheim group. They say that it's more unlikely that this falls on the same isochron. I would state maybe it's just a little bit of more contamination with lead, and it's still the same. But what you clearly see is that even our early Gurnia ingot from Crete is sitting on the same isochron that was defined by Berger colleagues. So this one. Okay, let's come to my conclusions. I would say that our Bochum LIA data set is in full agreement with the findings of the recent paper by Paul et al. Of course, we have two different ideas now. One is in favor of the European deposits with a group of Berger and colleagues. The other one is still more in the traditional idea that it's coming from Central Asian. Our own new results can add a little bit more high precision data to the current discussion on the use of isotopes. And for lead Bronze Age ingots, the high lead ingots clearly show an overlap with the Bolkadak region, and the field decreases with the new data. So it's even matching the Bolkadak data more perfectly. What I also can add here is that there is full consistency with the tin ingots from the Israeli sites. So they are perfectly sitting also on the isochron of the tin ingots from the Carmel coast. So we are searching deposits of 300 million years and more. So based on the lead isotope composition, a common origin of raw materials of low lead tin ingots from Uluburun, from the Carmel coast, and even going further to the, or back to the late Minoan 1A period at Giorno cannot be excluded. So I also run half of the samples for tin isotope analysis already. I don't want to present this data here. It's also a very small data set, of course, 8 to 8 ingots. And in the future, we also want to add the trace elemental composition, which is, of course, important then in the current discussion also about Indian contents, for example, for these set of ingots. Thank you.
Thank you, Moritz. It is a good news that Uluburun, Giorno, and Carmel could have the same origin. We will discuss this later. We pass now to the next speaker, Elin Figueiredo, who is, hi Elin, assistant researcher at the Center of Materials Research, Institute for Nanostructures, Nanomodeling and Nanofabrication at the Nova University in Lisbon. She has been working on archaeometallurgical projects for several years, and she is also coordinating the Iberian Tin project. And we are all very happy to have her here, of course. So Eileen, it is your turn.
Okay, thank you very much for the introduction. And thank you also for the invitation to be here in this roundtable. Well, I'll try and do my best since I'm going to be the only one talking on related things in Iberian Peninsula. Unfortunately, my colleagues in the morning could not give their talks. So I'll try my best to give some impressions about Iberian Peninsula, and namely on tin landscapes and some bronze metallurgy. So, of course, what I'm going to present is not just a work of my own. It has been done in the framework of some projects and with numerous people from various institutions. At the moment, we have the Iberian Tin project running, but well, there were other projects on the past in which I was involved, including my own PhD and postdocs work. So, related to tin, the team that works in this subject is multidisciplinary, and we look to different aspects from documental research to the geological field work. There was also a person on ethnoarchaeology, some experimental archaeology and mining landscapes, and also some archaeometry. I'll use this map since this one has not been used today. Many have come. The maps on, this is the Europe tin deposits from the 80s from Penellic. And here we see again, so the major tin fields in Central Europe, in UK, in France, and here in Iberian Peninsula, which is called generally the Iberian Tin Belt. So, the Iberian Tin Belt, here in more detail, so we have mapped all the tin mineralization records we have found. So this is the map we have done in the framework of the project. And just to give an idea of the area, let's say, so going from one point until this area here in central Spain, it's about 750 kilometers. So really it's a large area. So when we study or try to study some places, we have to point out some places, and many are left behind. Of course, many of these places are, some of them have been worked in the 20th century, others have not, or are unknown, have unknown previous works that have never been dated. So, and here just to give some glimpse of some cassiterite from some of the mines, and some we have collected ourselves. I'm going to make this talk with some examples. I thought it was more easy to do it like that. So I'll begin with this one, is the Tualatin mine. We are still with work in progress on this place. This place is interesting because it has evidences for protohistoric, or let's say Bronze Age tin mining. And how did we come with this place? Because in the 50s, a paper was published with what they called a prehistoric tool for processing supposedly cassiterite, yeah, because it was found in the Tualatin mine. So it was found during the mining works, the 20th century mining works. So we, based on this, we tried to dig back further and try to understand and get all the history of this place, because no paper has been written about this place. So it's difficult, even if in other works you want to reference it, there has been no work really putting all the data into context. So we went to geological museums. These are just some of the pictures from the one in Oporto. And there was not just that piece that was there. There were others from the same place, from Ervedosa. And also, well, these are just some samples there from the geological museum from the area or nearby, just for a picture here. And about this one, we are not sure. In the catalogum they had, it said it was from Ervedosa, but we are not so sure. But here, then we have these ones, we are sure about them. And you can even see the old writing here saying Ervedosa. Going to the mine, nowadays it is a big, huge hole, let's say in the mountain. This is from the top view. Here is on the bottom. So you can see here the area up. Here's a person here. And it's still possible to see cassiterite in some veins here that we can sample, of course, and we did. These are just some examples of some analysis, some EDXRF analysis of some of the cassiterites, just to show that, well, besides tin, they also commonly have niobium, tantalum, iron, and also sometimes tungsten, although I think in these examples there's not, but they can also have other elements present, either in cassiterite or in some cases in the gangue that is mixtured. We also went to the archives, the mining archives, to try to understand the mining processes, to try to understand where exactly were those tools, ancient tools found, because they said in which gallery they were working when they found them. So we made that work back. And we also mapped here, you can see the Ervedosa mine. And all these places here are fortified settlements. We just call them fortified. We don't know their age, if they are Bronze Age, Iron Age. None of them has ever been excavated. So here is an orthophoto of the place. And here was the location, of course, now completely disintegrated, but where those mining tools or processing tools were found. So this is the Tuala mining place. Nearby, when we were doing also the context, we also found this cerro that was quite interesting, and we found also some more than 100, well, about 100 years papers talking about holes in this cerro. So we went there, we did some days of prospection, and we found also evidences of ancient mining. Well, we have no idea at this moment for what, but we can see here they have like this round fire set type of entrances here. It goes down. In this case, we tried going down, but it has been collapsed. It collapsed, so there is no way of going much more down than this. So this is another place, but well, that could have some interest. Although we were not able to get in to see if we could find any evidences or traces of the minerals that were being worked or mined here. Giving another example, here it's, I'm going to, now we were here and now we are coming a little bit more to the coast. So in the region of Viana do Castelo, there are many, many mines there. This is just a map with mining concessions that were given in the 20th century, just for you to have an idea that it's very rich in tin, all these areas. You can also find tungsten and some gold and some iron. But we went to this area here because in LIDAR, this is an area that has LIDAR coverage. I must emphasize that Portugal does not have LIDAR coverage of the total area as does Spain, but Portugal does not. And at this moment, there was this area done. So here we have these three zones and a highway that goes through them. So it most likely damaged here most of this area. We can see it here on with other kind of views, and with orthophotos like this is not possible. There's a lot of vegetation now, but these areas were interesting because we could do some field work and go to the places and also manage the LiDAR data, so the digital model plans. And also, as we knew that the concessions of the mines, the modern ones, were in the 40s, we could also get access to old orthophotos from the region, from plains. So we could kind of monitorize the mining activity, if there was any, in the 20th century, in the mid 20th century. So that was what we did, together with the mining archives from those mines that we also went looking for. So in this region here, this is the modern, let's say for the 20th century mining works. From all this, they were already covered with vegetation during all those floods. So we know they are before this date. We do not really know from when. They could be, let's say, Roman, they could be medieval, they could be even earlier. Really, there is no idea. We don't have an idea. But it is important to show, because actually these places, and they are not small, they are there, and nobody really ever looked at them. And even when the only places where we found that someone talked about them said they were Roman gold mining works. So nothing seems to be very consistent. And here we also could doing some work, probably we could distinguish 4 mining faces, and also some canals and water tank structures. These are just some cross sections. I'm going to pass this. Here an image of this kind of water tank at the top. So you can see there's a lot of vegetation, and this we consider is a very good area for doing prospection. You can see here on the other side, full of trees, and there's also a lot of mining vestiges there, but the LiDAR did not pass through the leaves, so we could not get a good coverage data. And also walking through this forest is not easy. So these 3 places were the ones that we could look to. We took some fine sediments also and separated the heavier parts from the other ones. So we could find also cassiterite, and this is in agreement with what we knew about the area, that it should have been mined for cassiterite. And here just a picture of the other zone, the Zolas zone. So you can see, well, if this is 150 meters, you can see this is a very big area. And here is the motorway that just cutted it, and there's more on the other side. And this area was even more difficult to go to in the field. There were just some places that were open. And here we can see this is kind of a pit with 10 meters of height. And here are some evidences of 20th century small size mining. So actually it's quite interesting that this area was not touched during those years in the 20th century. Of course, that our idea after this was to get in contact with the owners of the places, of the areas, to be able to do some archaeological excavation or so, having already all this study done previously, so we could select some good areas where possibly we could get some profile and maybe have materials or be able to date by luminescence or some other way. But it was not possible. We had the municipality also tried to help us getting in contact with proprietaries, but it was not possible because, as it seems, old proprietaries that died did not put the papers right for the next ones, for the next generation. So in many cases, we don't know who are the owners. Nobody knows, not even the municipality. So we get stuck here, but all this work is done. So if we have any possibility in the future, we already know the best places to go for. So another another case study was the Carvalheiros Hill Fort. So this was a place that was very important for us because we found evidence for tin production in this place. So it's named the Castro in Iberia. It's a hill fort, generally from Iron Age, but it can begin in Bronze Age also. And this one has here, as we can see, walls, ditches, and there was also a chevaux de frise field that is not seen in these old pictures. Nowadays, this is full of vegetation and trees. So this is like a picture from the 40s or from the 50s. In the surroundings, we also, in archives, we also found pictures from the Carvalheiros region with mining places, tin mining places. These are some photographs. They are not dated. We put them as middle 20th century. But we were also lucky to find a map from the beginning of the 20th century from prospectors. So this was a map to prospect for future mining places. And they mapped here what they called old excavations. So we could see that there was already existing old excavations in this place. And this is interesting. We went to those places. Some of them, one of them had been destroyed by the road, but these were not. And here are just two examples of those areas. These are materials. So it has not been dated, the place has not been dated, but based on the materials, It is supposed to be on the 2nd or 1st century, let's say. But what was interesting for us was kind of slag materials, and these 3 in particular. So these 3, what they are tin slags. And tin slags, when I say tin slags, I don't mean bronze slags. I mean, they are slags from smelting tin, cassiterite. I mean, from smelting cassiterite to produce tin, to produce metallic tin. So, and here are some of, these are XRF results, bulk results, and we can see also here the other elements that commonly appear in cassiterite, and this is some microstructure where we can see also some dendrites very rich in niobium and tantalum, besides some metallic cassiterite that also is present in some places as globules. So that was Castro de Carvalheiros, and now we are still with work in progress in Outeiro de Baltar. And this is also a hill fort, but it was also a mining place. So it was actually found during mining works in the 20th century, mining works for tin. And the mining company found during the mining works many objects, archaeological objects. Unfortunately, they put them all together and they gave them to the museum, the local museum. So that was good. Yeah, I don't know if I'm taking too much time. Is it okay? No?
I suppose you are the last one, and I suppose it is okay. Then we can ask for discussion, but we also have an addition.
Okay. So I'll try to go a little bit faster. We made the same process. So we went through archives and to try and understand where those materials were found during the mining works. And we also went to the museum. And in the museum, what we were interested in was not the artifacts themselves, but the small metallurgical debris and this kind of stuff that was inside some, some cases, all mixtured together. So we pinpoint kind of made some analysis, and what we found in one of them was very interesting again. So it was a tin slag, and this one was given in the museum as a tungsten, but no, it's a cassiterite, and makes one wonder why did the workers, they put this cassiterite piece together with all the archaeological ones and gave them to the museum. Probably they found them together and they knew this was not of their mining, whatever work, but it's also in the collection of this site. This site also work in progress, and beside the tin slag, we also took some nodules, and we could study the kind of metallurgy that was being done in this place. So it was a bronze metallurgy. These nodules, they have some lead, less than 10%. This is Iron Age, by the way. And in the tin slag, we can see again all those elements, although in the microstructure, it does not have such a complex microstructure as the one before. So to give here an idea about pre-medieval tin slags, they are really rare. At the time of this paper, I could just put together in Western Europe 4 places. Then I added cassiterite, hill fort, and now I can add Outeiro de Baltar. And so from these 6 places I know with tin slags, pre-medieval ones, 3 are from Iberian Peninsula. This is the last place. I'll just skip a little bit, or yeah, Alessandra, do I have some minutes? Yeah. So just to touch a little bit, bronze metallurgy. I don't listen.
If you can make it short.
Fast. Okay.
You can show it later as well.
Yeah, okay. Okay, so this is an area that I've been studying for many years, and now we are studying it again because of the cassiterite and some other pieces. What is best known is the Bayonne place. Probably most of the archaeologists know it. It has Mediterranean and Atlantic affiliated artifacts. It even has, I just saw in the morning some bowls of metal. So coming, I don't know if it was from Cyprus or so, but Bayonnes also have round bowls, metal bowls. These are flesh hooks. I also saw a map that didn't include these flesh hooks. So these are very nice flesh hooks in Bayonnes. There's also a lot of gold. And here are some of the pulse staffs. Also, there is production items. So these are molds to make pulse staffs. This one is in metal, in bronze, but there are also fragments in ceramics and sickles. And well, this has a lot of interesting things. But again, it was not at that we looked at the time. We went for the metallurgical debris. And I'll just pinpoint here two things. One was a slag sample. So there was also some production at the place involving bronze. And also this metallic nodule that I found very interesting that gives us it shows us that some metallic tin must have also been involved, because this is an interdiffusion that can only occur if there is metallic tin. I will not go into the details right now. And here to have also an idea of the late Bronze Age composition of the metals in central Portugal. This is already from some years collection I made, but it is still updated. If we add more, it will fill up with this pattern. So what we can find is that the indigenous metallurgical tradition, they had a tin content of about 13%. It's not common to find low tin bronzes at this stage. And also the lead is generally always under 1%. So just going back a little bit, this is some earlier ones where you can see a higher dispersion. So, and okay. Here I skip, and this also. So.
Thank you very much, Eileen. I'm sorry I had to hurry this, but we also have an addition. I would like to invite Tom Brogan, our director, the director of the study center here in Pachiamos, in Eastern Crete, and he's going to give some information on the tin finds in Crete. Tom, are you there? Can you hear me? He should be there. Ok.
Un attimo, solo sta entrando.
Okay, Alessandra, can you hear me?
Yes, yes.
Ah, there we go. Okay, super.
Excellent.
And I can see Fulvio. Okay, so
yes.
Thank you, Alessandra, for inviting me as a last-minute parachute into your program. And I'm happy to say a few words. So Alessandra's invited me to mention a new find on Crete, which links nicely with Morris Janssen's paper and the earlier publication of Daniel Berger that's been referred to many times today it's round table. This is a discovery 2 years ago on the island of Crete, which is in eastern Crete off the south coast of Crete. Those of you who are familiar, you've seen the sites of Moklos and Gornia that were mentioned earlier. Crete is an island where excavations recently by the Greek Ministry of Culture, the Lassithi branch under the direction of Chrysa Sofianou, have excavated an important building at a site which is producing extremely large amounts of purple dye in the 15th century, well, all the way from the 18th century BC, but The find we're going to talk about is from the 15th century BC. The site of Crecy, sort of 5 or 6 buildings have been excavated, and there appears to be a large central building, which is still under investigation. And 2 years ago, Crecy Sophia New's team excavated a hoard of metal objects that included several fragments of copper ingot. I think there were 19 or 20 pieces altogether, a complete ingot, a half of ingot. Altogether, the pieces weigh 68 kilograms. So you're imagining more than 2 copper ingots in this deposit. With that, were found a bent saw and a bronze bowl with relief, a floral relief pattern on it of crocuses. And inside the bowl was a large amount of tin. And that tin, and this find has now been published preliminarily in the newsletter of the which we call the Kendra, volume 23 in 2020. And so if you go to the website of the INSTAP Study Center, you can Google that and look at the latest issue. You can find a photograph and a 5-page description of this find by Crecy Sophia New, and one publication showing the bowl with the tin inside it. So this find comes from a destruction level that's probably dated around 1450 BC. And anyway, it's the 3rd terrestrial find of tin on the island of Crete, all of them in the 2nd Palace period horizon. So this is the acme of Minoan palatial culture. And the sites, now you've heard Moklos, Gornia, and Crecy, all appear to be sort of secondary centers in a Minoan palace system. Maybe Gornia is a regional center. Moklos and Crecy are harbor towns, very well connected with this. Anyway, the tin comes from this horizon. And I guess something you might want to know, going back to Morris's paper, you've got 3 finds in Crete, 2 on the north coast, 1 on the south coast. The find from Gornia is probably the earliest. It's from an LM1A level, as Morris said, right before the Therian eruption. The find from Moklos, which is published in Berge et al. 2019, that comes from a foundation deposit in a building built right after the eruption, so soon after the eruption. And then the Crecy find comes at the end of the LM1B period, so around 1450 BC. So these 3 finds are all in different windows within this Neopalatial period. One sort of earlier in the 16th century, one at the end of the 16th century, and one in the middle of the 15th century. Anyway, I think the only other thing I would add is that I guess the premise of the paper in Berger that it's a watershed, all things sort of changing directions afterwards. But as Morris said, the finds from Moklos have been linked to trade networks in the Near East. And Morris seemed to be implying the same for the Gornia, the compositions are the same. And at least in the case of Moklos and Gornia and Crecy, the new finds, there's a lot of corroborating evidence in the form of jewelry that links to artifacts being collected on trade routes coming from Egypt along the Syro-Palestinian coast, past Cyprus to pick up the copper ingots, and entering these emporia on the east coast of Crete. So there's a lot of corroborating evidence that suggests an eastward trajectory for the tin and other artifacts. But I think that's what Alessandra wanted me to tell you. The new artifacts have not yet been analyzed, but Alessandra is part of a team that's working with Crecy Sophia New to bring new discoveries to light. But anyway, thank you for inviting me. I enjoyed the conference, the roundtable, very much. We look at things from a site perspective. Obviously, most of you in this paper are looking at things from a much more global perspective. So it's always good to have the 2 sides meet.
Thank you very, very much, Tom. Fulvia is applauding you. This was the last speaker today. And then now we are going back to the discussion. And I think I'm going to give, to ask Sofia, perhaps, to comment on the various answers and questions she received during various presentations today. If you want to say something.
Thank you very much. I'm not sure that I'm the best person here to lead this discussion, because obviously in the last years there has been
I'd like You would like to give some comments or answers to the
comments. I am immensely, oh yes, okay. I'm immensely impressed by the work which is going on, honestly. I'm very pleased to see that Bochum has the new multi-collector mass spectrometer, because it means one more laboratory where the analysis can be done. At the moment, there is we talk a lot about lead isotope analysis and about how useful it would be to have more. But the problem is that there are not many laboratories, apart from Mannheim, where you can just go and pay and get the analysis done very quickly. Everyone does it sort of by themselves in their own group. So it's not easy to get a commercial laboratory to do analysis, but the more laboratories, the more easy to do the work. The other comment which I would like to make is this new evidence of tin working in Portugal. This is fantastic. That's really something which is quite new in a way. There were some papers before about tin and copper co-smelting in Portugal, but this actually field work adds incredibly a lot of information. So this is fantastic. The work on the ingots and tin is so important, because we need to link it all together. As you have heard in my talk before, I said that I don't really quite believe that copper from Sardinia was widely traded. I rather say tin, where we know that tin from Sardinia is really not believable. So I really think that it would be good if there is further research can in some way tighten up this idea of Sardinia being the hub for exchange of metals. And we know that in the second millennium BC, the second part of second millennium BC, metals were extremely important, tin and copper. It's also interesting why silver was not exploited on Sardinia, why this knowledge of extraction of silver from Eastern Mediterranean, where silver was extracted since third millennium BC from Galena. It seems that on Sardinia, somehow this was ignored, and then we know that there are deposits of silver. So I think there's so much to do to base on what we already know and to take it further. But elemental analysis, fieldwork is very important. That's very good. But elemental and lead isotope analysis combined, I think, is the way forward to identify more information about the metals and the metal trade. So thank you very much. I'm really very impressed by all the papers which we had this afternoon.
Thank you, Sofia. Maybe Fulvia would like to say something. Am I wrong? You have to switch on
Yes. I have a question for Gilberto. Is he here? Gilberto Artioli, is he here? Oh, yes, please, Gilberto. Probably I made some confusion, but I didn't understood what you exactly said about the provenance, if possible, of the two little jugs and of the ingots from Villagrande Strisaili.
I said that there are several sources, I think. The main one, which is coinciding with the tin circulating in the second half of the millennium in northern Italy, is very similar to what we are discussing for the Eastern Mediterranean ingots. So if we solve the question about the ingots being from the Tian Shan region in China rather than Iberia, is the same source of the circulating tin in Sardinia.
That is the ingots from Villagrande Strisaili, and the two jugs are mixed sources, possibly coming from China.
There is one main source, which is the same one of the circulating ingots in the Eastern Mediterranean, but there are a couple of ingots which are different. So there might be different sources.
Thank you. It's better that I don't go on making comments, but indeed I am absolutely shocked by the high level of all the research which are really going on, and the level is absolutely fantastic. Some question, I don't remember which one, on the bronze figurines. I don't discuss about the chronology because it is too low, the one they said, but the analysis, they say they have a low content of lead in the figurines. We know that all the figurines we analyzed have a very high lead content. But this is not a question for Gilberto, it's for
Daniel.
Daniel, yeah.
Yes. The one you have analyzed have low lead content, because the one we knew, one of this figurine we call the piombetto, because it was mostly lead than copper. So it is strange that we found low lead content in the bronze figurines. In some of the figurines we think are 3 alloy components, because there is tin and not so much, copper and lead, a lot of lead.
So how high were the lead levels in your samples, in your figurines?
Yes, a lot.
Up to 10% or even higher, or?
Yes.
Okay.
Yes.
Okay, so that's the situation that we found
yes.
with our samples. I can't say so much about the other analysis or the figurines that you analyzed, because I'm not aware about it or aware of it. But what we find actually is that there is at least a group which is characterized by low lead levels, and another group that is characterized by fairly higher.
And these groups are in different provenance, different groups from different sites, or mixed.
In case of the bronze figurines from Sumonte, we observed the higher lead levels, and these show a different history of production, and also a different sources, or we argue that different sources were mixed in this case, and probably there's a one kind or one sort of copper that is or have the bronzes from Santa Vittoria in common with the Sumonte bronzes. So probably there was also a mixture between the bronzes from Sumonte and Santa Vittoria.
Yes,
so
yes,
it seems a complex picture that we established here, and we have to figure out it in the future what is really behind it.
I absolutely agree, as I do agree to the fact that we have no archaeological traces of recycling, and instead there is a wide circulation of objects. So if when looters, we found things coming from looting, we are unable to say exactly from what place they come from, because there is a absolutely wide circulation.
Yeah, unfortunately.
That's very, very interesting. Another question I think was no, I don't remember who said something about low, probably was Ignacio, saying that we have not enough pre-neuralgic analysis. Was it Ignacio?
Yes.
Yes, I'm here.
Yes, oh, hello, Ida. The point is that, as you well know, pre-neuralgic metals are thin, are very, very thin sheets or very much corroded pieces of holes. We have plenty of holes, but you cannot make a good analysis of holes because there is nothing left. And we tried in the group of bronze, of silver object coming from late beginning of Chalcolithic site of Sukunjao Esatutta, analyzed in 2005. There was no possibility of making an analysis because the materials were absolutely not
corroded.
sufficient.
Corroded.
Yeah.
Okay, but my question was about lead isotopes. So I know that there are some objects that has elemental analysis or chemical analysis, and we know that there are some arsenical coppers in the early metallurgy of Sardinia, but none of these objects have lead isotopes. So we don't know exactly what copper resources were in use at this early age.
Yes.
Is this a clue to understand the use of the copper in the island?
Let us hope that we found a piece as good as the one from Bausu Matutsu. Bausu Matutsu is a solid piece of metal. This could be analyzed as a provenance, but the other, what I studied, 15 daggers coming from Monte Claro, sealed situation, are mostly corrosion.
Yes, but in lead isotope analysis, some corrosion could be useful for get a signature. So probably if you are not taking the sample on surface, but if you could take the corroded inside, you can get results from lead isotopes and give information about this early use of copper in the island.
There is not much inside left. What I mean is the pieces are very thin and very much corroded both sides. So inside there's not much. But in any case, I took that as a invite you to look very carefully to our preneuralgic metal, the copper daggers. I just finished a long paper about all preneuralgic metallurgy, so you can choose.
Yes, remember you invite me to study the Fontana Coperta, and we're in a big trouble.
No, that's splendid. That's splendid. I congratulate with myself because I invited you.
Maybe I can make just a small comment. I mean, we analyzed, and this goes back to the silver that Sophia was talking about. We analyzed a small in Piedmont, and is made of end of Neolithic, and is made of Sardinian silver, maybe native silver, we don't know, but definitely Sardinian. And we analyzed about 10 holes, very small, some corroded from northern Italy. They're all from Balkans. And even if there are minute quantities, I mean, you can definitely get the signal of the lead isotope out.
Yeah, this is what I wanted to say. The two things actually came to my mind now. One thing is that the amount of sample you need now for multi-collector mass spectrometry is really very small, much smaller than what we needed for TIMS. But the other thing which occurred to me listening to both Gilberto and Daniel, that this question of which mines could have been used. And I think that from lead isotope analysis, now there are I can list here 3 mines which I have seen signatures of amongst the Sardinian artifacts. And Daniel mentioned the same. This is Saducessa, or Saducessa, don't know how to pronounce it, Pranu Esangui, and the ones in Iglesiente, another one in Iglesiente, and Calabona. They are the ones which come up in signatures. And indeed, Fontana Raminosa is not visible very much. So it's something which one could perhaps start by doing analysis of, making analysis of isotope analysis of Sardinian artifacts, and then try to identify the mines and then combine the field work with this information. Perhaps this way one could get somewhere to identify which mines might have been used. Yeah, I finished.
Maybe let me have just a small comment on this. I fully agree with what we said before, that there was no massive exploitation of copper in Sardinia, because it's really not a copper island. And also Fontana Luminosa, in our mind, is a very important mine because it was exploited in modern times. Whereas I think what we are looking at is a very small, as Ignacio showed very, very clearly. I mean, it's very small scale operations where you need just, very small outcrops. And this could actually not be related to the major outcrop of Fontana Luminosa, actually most of the others.
Yeah. But lead isotopes perhaps is the way. And also the other thing which is totally lacking, I think, in Sardinia is a good elemental characterization of these copper minerals. Would you agree with that? There's no, I haven't seen a good elemental data, which again should rely on the modern ICP-MS analysis, perhaps. So I think there's a lot to do and a lot to discover.
Yeah. Let me add something because Sophia, you mentioned that the multi-parameter analysis, meaning we have to look on the lead isotope composition, to look on the trace element composition in case of copper. But we have also the possibility to look on other parameters such as the tin isotope composition. We can use the copper isotope composition as well. We also did, and this is a very interesting point, we also did osmium isotope, first osmium isotope analysis on the nuragic bronzetti. And interestingly, we found a very distinctive, a very radiogenic osmium isotope composition, and this could perhaps help to clarify the overlap with the Sinai ore or the Red Sea ores, because as Ignacio mentioned, there's a very heavy or strong overlap between these two regions, and perhaps the osmium isotope composition in this case can help us because we also analyzed some of the copper ores from the Sinai, from Timna or and Fenan. I'm not clearly sure, and they show completely different osmium isotope composition. So in this case, we can use the osmium isotope composition to clarify the situation a little bit more. And in my opinion, it will be very important in the future to use much more information from different isotope systems, from the element, from the trace elements, and try to put all the things together. I know it becomes very huge data set and very confusing sometimes, but it can, and I'm convinced that it helps us. It helps us because also the question of mixing of metals, and this is a point that is often ignored, I say. Often ignored when we are dealing with lead isotopes. Okay, lead isotopes are very helpful, but in case when it comes to mixing, it could be also be problems or give problems with lead isotopes. But when we combine it with other isotope systems, with the copper isotopes, with lead, the tin isotopes, we can establish mixing lines across artifacts, across regions, and this could give us insights into the metallurgical practices or into trading networks. We are just at the beginning to understand what we can do with this information. But I think we have now a very large
Now,
very
can I
large,
be a sport?
yeah.
I agree with you entirely. It all sounds wonderful. And I know I'm a scientist. I love it. But it costs a lot of money to do it.
That's the
And,
point.
you know, you have to have a laboratory and you have to have the money to run this laboratory. In Oxford, we have failed completely because we couldn't find enough money to run it. And we just couldn't go ahead because we didn't have enough financial support.
Yes.
Mannheim is doing very well doing commercial work, but they also have a substantial funds, private funds, I understand. Well, at least to set it up, they had.
Yeah, to set it up. Okay, that's right. But but now we have no private funds anymore.
But you know, generally, I see that this is what I have been saying 30 years ago, that there should be, say, European Union. There should be a laboratory established by the European community for this sort of work, which what you are saying, you know, you would be a perfect leader for this.
No, I'm not a leader.
With your enthusiasm and your knowledge. But this is what is needed. There is needed a place. I work now with Polish archaeologists. We are doing fantastic work. First time in Poland, there are lead isotopes done on metals. And for example, there are found, you know, different parts of Poland, they have copper from different regions of Europe, completely different picture images than what they were thinking was happening. And they come to me and say, tell me, where can I have the analysis done? Chemical analysis, lead isotope analysis, where can I have it done? And there is a difficulty, you know, it's not so easy just to click on the internet and find the lab which would give you the data and doesn't require the payment. But because to be honest, Mannheim is quite expensive.
Of course.
It's and they have to keep going. I'm not surprised, but there should be. I am evaluating projects for European Commission. You know, for previously for Horizon. Now I'm going to be involved in this next one. There is no talk of a possible funds for this sort of archaeological work. Still, archaeology is a low-funded project. The Scandinavian project has gone very well because they were able to get the money from the government. Otherwise, you know, in a country like Poland, it's not so easy. The same, I suppose, is in Italy and you know, Greece for sure. It doesn't have the resources. So let's, you know, someone has to get together and organize, I don't know, a pressure group, a discussion group, something to create the environment where this sort of analysis could be done. And then the same with strontium analysis, with, you know, other scientific analysis of archaeological artifacts. So I think the future is fantastic, providing that someone is prepared to pay for it.
Right.
I would like to ask Alan Williams, for example, if he has comments or some questions to other speakers. Would you like to?
Well, not a great deal, but basically to say how excellent work's been done by Daniel there. Fantastic paper, fantastic work, and we're counting on him supporting our project as well, which I thank very much from. I mean, from our point of view, our project's really just starting. It's been delayed somewhat, but we've now got a good set of samples, and this session today has been very useful input in understanding the latest thinking on that. And it's very, very interesting that the information on ingots in the Mediterranean are coming together to indicate that they'd be consistent with coming potentially from one area. But I mean, I think one observation I would make is, you know, we've got hugely rich cassiterite deposits in Iberia. You know, it's much bigger than Cornwall, as was pointed out. And I'm sure that, you know, over time that cassiterite was worked in many places, all the places potentially in Europe where cassiterite was formed. And we're talking a long time period. So you know, we're interested particularly in the early period, and that bronzitization push that came, you know, what was Cornwall's role in that? But clearly, you know, Iberia, Erzgebirge, there's some new evidence perhaps that Erzgebirge was worked early as well. So I think it's a whole complex. It's not just one area. It's how everything worked together, and perhaps, you know, was one area more dominant the other for periods of time, etc. And how did it all evolve? And this bronzitization thing particularly is of interest to us. So there's, I think it's a complex picture over a long period of time, and there's many differences and nuances that will emerge. And I think all working together, we can hopefully start to make inroads into that picture. Thank you.
Right, thank you. I would also ask Moritz if he has something to ask or to comment about. I think we are having some problems here in Crete. We were stuck just before, and we connected it again. I hope it works.
Yeah, we hear you very well.
Works fine.
Yeah, okay. Thank you.
Yeah. So for me, of course, just having started this new lab, it's still my daily business at the moment to establish things. So also in the field of tin, I'm fairly new, of course, but it was great to see how much work is done on tin, of course. And so it was, yeah, a great opportunity for me to take part in this workshop today. One thing this is a question for Daniel, I guess, the question of indium in tin and tying that to a specific region. As far as I know, indium is a typical element of skarn deposits, and skarn deposits are, of course, abundant in the world. So I just for my feeling, theoretically, I guess Tien Shan deposit could produce the same isochrone like Cornwall or the Erzgebirge would do. And then we wouldn't have a clear fingerprint to distinguish that. But do you think that indium is really helpful to be sure about specific trade routes, or?
No, I'm not sure about it, because in our paper from 2019, I reviewed just a couple of the possible tin ores and a couple of cassiterite, analysis on cassiterite, and it was just a preliminary conclusion that the indium concentration could be a helpful one, just because the highest indium concentrations are found in at that time in cassiterite in Cornwall. That's as I said, just preliminary conclusions. So and that's the point, or the very how to say, it's very important to obtain much more analysis on cassiterite, and I'm very glad that Alan Williams and Ben Roberts and his project are covering now this problem, and trying to find out how the trace elements behave during the smelting process, because this is also a very important question, how to understand how the different trace elements behave during the smelting process, in order to get an understanding how much of the indium could enter the tin, how much of other trace elements could enter the tin, and I'm not convinced. I cannot be convinced that indium is a solution. I think it should be a combination of different trace elements. So also multi-parameter, so to say. And what I mentioned in my paper, the observation that some of the tin objects and some of the tin ores from Iberia have a lower tin concentration, indium concentration. It could probably just be a coincidence. Yeah, so it's not an exhaustive database. So we are just at a starting point, and I'm happy to. I'm looking forward to see what comes out in the next years from the different projects and from different from working groups. And I think we will make a lot of progress in the next years. But also in the case of tin, we should combine different parameters, the lead isotope composition, the trace elements, and also the tin isotope composition, which is not completely useless. I have to underline this.
Yes. I would also like to invite Elin to say something, if you have comments or questions. I wanted to ask, for the moment, there are no tin objects dated to the Bronze Age found in Portugal, or am I?
Well,
no objects, no finds, no ingots, and it is amazing because of this huge tin deposit. It never happened.
Well, we know there is, like in Galicia, just north of Portugal, we know that it was found tin ingots in the terrain, because we found in an old writing of Monteagudo. I don't know if you know this name, the person who made all the access from the Iberian Peninsula.
Yes, yes.
Yeah. And we found a paper that he wrote, and in a short note, he even that he found, it was given to him from a place in Galicia, tin ingots that were found on the terrain, and he even analyzed them. He puts there that it is very poor tin, and we tried to track back that, but we were not lucky. Also, I know there's a tin piece from another place that is known mainly from Chalcolithic and early Bronze Age, but it has never been published. And it has never been published because I think those who found it very strange and could not put it inside a history, so they never published it. So I think sometimes there might be some things, but either they are not published or they are not
somewhere in some
place, but not artifacts like, I would say, an entire artifact in tin. No, like something like that, an entire artifact made of tin. I know there are some tin fibulas from Spain. I think Ignacio Montero might know a bit better about that, but maybe they are Iron Age. There was some papers some 10 years ago or 20 years ago about tin. I don't know if they were fibulas.
I don't remember.
Tin fibulas.
I don't remember.
I don't know if you were involved in that. Yeah. So yes, but what I find interesting is, like, during Bronze Age is the very, how can I call it? Well, in my perspective, the tin content in the bronze objects is always very sharp. Well, if we say this is ancient metallurgy, not done with the parameters of nowadays. For me it's like if I get samples or bronze material and it's probably from, and it's told me it's probably from late Bronze Age, it's like certainly the chemical composition is always like the same, more or less. It's always on that 13%, between 10 and 15% tin, and very low in the other components. So that makes me think they were, of course, not short of tin.
Yes, definitely.
They were not short of tin. And I think one of the questions here is, did they added cassiterite directly to some metallurgical kind of smelting process, or did they did it separately? So smelting cassiterite to make tin, and copper and malachite or whatever to make copper, and then added that together. So this is also a question. We, interestingly, from ethnographic data from the 20th century in north of Portugal and Galicia, and during the Second World War, when there was also a lot of mining and traffic mine from many elements, the copper was trafficked in the copper metallic state, and tin was always trafficked in cassiterite, not as the tin metal. It's interesting. I don't know if we could do some human or metallurgical analogy, but yeah. And yes, I think there are some questions and we don't know very well the answers. So of course the work that we are doing, it takes time and it's not easy, because going to the terrain, doing all this, going to back documentation, even in the archives that are mining archives, there are some of them and I have to say, some of them we do not get authorization to get the information. And now because of the lithium interest, we have been denied to get access to some mining archives of some places. So, well, yeah.
May I ask just a question?
I have.
Sorry.
Sorry. The first question is, will this be published?
Well, our project is also a bit delayed, and all this COVID questions is also delayed us a lot. We have now got into the last year, and we are going to try to publish as much as we can, let's say, in this last year. But for sure, I know that the project, the financing finishes, and probably we'll still have data working and coming after. So, yeah.
I think it was a question for Fulvia as well. The other problem I have now is that we have to go out of the institute. I'm very sorry.
The same for us. We must leave this.
Yeah, we must leave now. I'm very sorry. I think Fulvia will send the circular mail, or Mauro Pera, about the publication.
Yes.
I suppose. And I have to say goodbye to everybody. Thank you very much for your big help with this enterprise. And I hope to hear from you soon. Thank you. Bye.
Bye-bye.